Hello students, today we'll be learning about reaction intermediates in brief. In any chemical reaction, reactants react to give products. But this is not the complete picture. What really happens is that first reactants react to give some intermediate, and this intermediate decomposes to give the products. In any non-concerted reaction, the bond breaking prior to the formation of new bond in the product, it gives rise to the formation of a highly energetic chemical species having very short half-life. This is called reaction intermediate. Reaction intermediates are of various types: carbocations, carbanions, carbenes, nitrines, and free radicals. Carbocations are positively charged chemical species containing 6 electrons in its valence shell after sharing, and they are not stable because they lack octet configuration of electrons. Coming to the stability of carbocation, tertiary carbocation is more stable than secondary carbocation, then primary, then methyl carbocation. This can be explained using hyperconjugation concept and plus I inductive effect. Here we have more plus I inductive effect, more stable. Here we can draw more hyperconjugative structures, more stable. Coming to carbanions, carbanions are those reaction intermediates where carbon contains negatively charged. Take this species, bond between C and H, carbon is more electronegative, so bond will be broken heterolytically. Thus, carbon is acquiring negative charge. So this species is carbanion. Stability of carbanion: methyl carbanion is more stable than primary carbanion, then secondary and tertiary carbanion. Let's understand this order of stability. Taking an example, if somebody is already rich, many relatives are there, these relatives are richer again, so they are giving money to this carbon. So carbon now will have lots and lots of money. That means what? More chance of being attacked, hijacked, very unstable. So lesser the number of R groups, lesser will be the electron density around carbon, lesser will be the electron repulsion, and more stability will be of the carbanion. So stability of carbanion will be inversely proportional to plus I effect. If the plus I effect is more, the stability of the carbanion decreases because of the increased electron repulsion, or you can say interelectronic repulsions. And here, more the percentage of S character, more will be the electron density closer to the nucleus, and it will be more stable. Let's take an alkene. Alkyne, alkene, and alkane. In alkyne, carbon is sp hybridized, it is sp2 hybridized, and in alkane it is sp3 hybridized. Here the percentage of S character will be 50%. Percentage of S character is 33.3%, and percentage of S character will be 25%. More the percentage of S character. So now from here, let's make it carbanion at C triple bonded C minus. Now this carbon is sp hybridized, 50% S character. More the percentage of S character, more will be the electron density closer to the nucleus, and hence this species will be more stable. So this species is more stable than this because of the more percentage of S character. Coming to carbenes, carbenes are those reaction intermediates where carbon is divalent, and carbon which is divalent has 6 valence electrons, and carbon has an unshared pair of electrons. So how carbons are formed? Let's take an example. So you treat chloroform with the base. Base will abstract the proton, and this shared for the electron will be taken up by this carbon. So the carbon will become negatively charged with 3 chlorine. So now there will be rearrangement of the electrons. So this 1 chlorine is leaving, minus Cl, and thus this species is generated. This is dichlorocarbene. Why carbene? Because it is divalent. 2 bonds are there. 6 valence electrons. How 6? 2, 4, 6. This carbon has 6 valence electrons after sharing, and it has 1 unshared electron pair. This is the unshared electron pair. Now carbons can be of 2 types. Let's say this is dichlorocarbene, and now if both the electrons are parallel to each other, it is triplet. If the electrons are antiparallel to each other, it's called singlet. Singlet is more stable than triplet because here inter-electronic repulsion is less. So stability of carbons depends on the inter-electronic repulsion. Free radicals. Free radicals are neutral non-polar chemical species. In free radicals we have 3 bonds and 1 single odd electron. Let's understand how free radicals are formed. You take one molecule, H, methane. Now this shared by the electron is a covalent bond. If you treat with H nu or sunlight, then what happens in presence of peroxide? So what happens? Homolysis takes place. Symmetrical way of bond cleavage takes place. As a result, we get this, and it is called free radical. So what is the definition? It is a neutral non-polar species. Why neutral? Because it is neither negatively charged nor positively charged. It is neutral, and it has 3 bonds, 1, 2, 3 bonds, and it has 1 single odd electron, 1 single odd electron. So in the valence shell of any carbon free radical we have 7 electrons, and these carbon free radicals, they are unstable because they lack octet. Here we have 7 electrons after sharing. They want to complete their octet by means of taking 1 electron from any other species, so they are reactive, they are less stable. They want to complete their octet. Now if you have more alkyl groups, they are electron deficient. If you have more alkyl groups attached to carbon which contains odd electron, they will exert plus I effect, and more plus I effect means they are pumping electrons towards the carbon which is electron deficient, making it more stable. So tertiary carbocation, tertiary carbon free radical is more stable than secondary carbon free radical, then primary carbon free radical, then methyl free radical. 3 alkyl groups, 2 alkyl groups, 1 alkyl group, no alkyl group. So the stability of carbon free radicals can be explained using inductive effect concept and hyperconjugation. More the number of alkyl groups, there will be more plus I effect, and hence the stability of the carbon free radical will be more. And if we have more alpha hydrogens, this is with respect to this alpha hydrogens, 9 alpha hydrogens, more the number of alpha hydrogens, more will be the hyperconjugation effect, and hence the more will be the stability. So next video will be on reactions of benzene. If you like my video, please press the like button below. and share to your friends and subscribe to my channel. Thank you.